Welcome to the Slop Farm. Enjoy the video.
You start by grabbing the raw screen space position, call input, mouse position and store the vector 3. Do this early in update so you have current coordinates each frame. Note why this matters. Unity reports pixels with origin at the bottom left, which affects UI overlays and comparisons. If you use the new input system, bind a pointer or mouse device instead, otherwise keep the legacy input call. Once done, quickly log the value to confirm pixel coordinates before converting to world or UI space. Next, convert that screen point to the space you need. For 3D world space, set a meaningful Z distance from camera and call camera. Screen to world point to get a vector 3 world position. For UI canvas in screen space or overlay, prefer rect transform utility. Screen point to local point in rectangle to get local coordinates inside a rect transform. Make sure to reference the correct camera. Main is convenient but cache it for performance. Once converted, apply position to objects or use for raycasts and interactions. Finally, choose interaction technique. For precise object picking, create a ray via camera. Screen point to ray input, mouse position and perform physics. Raycast with a layer mask to filter targets. For 2D, use physics 2D. Raycast with the converted world point. Make sure colliders and layers are set correctly, otherwise you get no hits. If UI clicks act odd, confirm canvas render mode and camera assignment. Troubleshooting tip: if positions mismatch, log screen versus converted coordinates and check camera transforms and canvas scaling.
Thanks for watching. Consider subscribing if we helped you today.